Section 4.3b, Right Triangle Trigonometry. Today we're going to talk about some applications of trigonometry, and first I want to teach you the concepts of elevation and depression. Now, elevation is a little bit easier than depression. We'll talk about elevation first. When we're referring to the angle of elevation, what we mean is this acute angle theta. And it's the acute angle that basically is from the horizon to the line of sight from the observer to an object. Okay, so if my observer is down here, his line of sight goes straight up along the hypotenuse to the object, and that acute angle is called the angle of elevation. Now, angle of depression is similar, but the reason it's a little less intuitive is because it's the angle that the observer's line of sight makes with the horizon, but in many cases that horizon is simply an invisible horizontal line. And we'll see why that's true with a word problem that we're going to do on the next or 2 screens from now. But in any case, it is the angle that the observer's line of sight makes with the horizon. Applications of trigonometric functions. Let's look at this first word problem. This is a typical trig word problem. And in Algebra 2, you might have done some simple problems like this, so this will probably be easy for you. When the sun is at an angle of elevation of 78.3 degrees to the east, the Washington Monument casts a shadow of 115 feet to the west. Find the height of the monument. Now, since this is your first trig word problem, I'm just going to give you a sketch that can help. And then in the future, of course, you'll draw all your own sketches. So look at what we have here on the right side of the screen. We've got our sun up in the upper right corner. Of course, in real life, the sun would be very much farther away from the earth than that. This is just for the sake of sketching. All right, and then we have our tower, and a block or a line is fine for a tower. I know that some students who like to draw, they get kind of intricate in their trig drawings, and they draw all kinds of details and people and faces and details on the buildings and roofs and windows and stuff. You can do that if you want, but it's probably going to waste your time, so I wouldn't recommend it. But what you do want to do whenever you're trying to sketch a trigonometric word problem is make sure that you draw your right triangle properly. All right, because that's the key to solving these problems. So the problem says that the sun is to the east. That's why I have it east of the tower. And the angle of elevation is 78.3 degrees. That's this acute angle theta here that I'm pointing to now with the mouse arrow. We have our shadow, which is 115 feet long. Now, just to clarify, of course, that 115 feet is only up to the beginning of the building. So right now where the mouse arrow is pointing, all right, right now where the mouse arrow is pointing, that specific spot is the end of the shadow. The 115 does not include the width of the building at all, and I hope that's sufficiently clear. The 115 is simply the shadow up to the beginning of the building, which is this point here. And the H is the height of the building, which we're trying to find. Okay, so using a trig function, figure out what H is, pause the video, do this on your own, and then resume when you have an answer. And you should have come up with tan 78.3 degrees equals H over 115, because H is the opposite, and as we know, tangent is opposite over adjacent. And the shadow is adjacent, so H over 115 is tan 78.3 degrees, and you can evaluate tan 78.3 degrees on your calculator, multiply it by 115 to get H, and you have 555.31 feet as the height of the Washington Monument. Now, of course, the top of the Washington Monument that I drew here doesn't have it doesn't have the triangular shape, the pyramidal shape on top, because as you know, the Washington Monument is an obelisk. But for the sake of simplicity, I just drew it as a rectangle. In any case, H is 555.31 feet. Now, one little point about using your calculators. This is very important. In the rest of this course, and also in calculus, sometimes you're going to be dealing with angles that are given in degrees, and sometimes you'll be dealing with angles that are given in radians. This angle here, of course, is given in degrees. And so what you have to do is make sure that your calculator's mode is set to degrees or radians, depending on what you want to do. And if you look at your calculators right now, there's a mode button right next to the second button near the top of the keypad. And if you press mode, you have a bunch of options, and one of those options is radian degree. So you simply select the one that you want to use, radian or degree. Alright, another one. A sniper with a laser rifle is hiding in a tower that is 50 feet high. His rifle's angle of depression is pi/7. How far away from him is the target? Alright, a couple things before you start this. First of all, notice that the angle is in radians. And the dead giveaway, well, there are two clues that you're dealing with radians. One is the fact that units aren't given, because technically radians have no units, as discussed in section 4.1. because they are simply the ratio of arc length to radius. And so, distance over distance, you have units canceling and you end up with just a ratio, a pure ratio, no units. So one clue is that the angle is given without units. That's how you know it's radians. And another clue is that it has pi in it. Now, of course, there are many times that radian angles are given without pi. They might be just given as a number, and that's fine. But if you ever see an angle given without units, it's a dead giveaway that you're dealing with radians. So make sure that the mode of your calculator is set to radians for this problem. Pause the video, try to do this on your own, and then resume if you get stuck or when you have an answer. So here's the drawing, and as I said before, the drawing is the key to the whole thing. If you draw correctly, then you'll be able to solve correctly. Okay, now if you got this drawing, that's great. You probably got the right answer. But if you didn't get this drawing, I want to explain to make sure that you understand where it comes from. Okay, so we have our tower, and it's 50 feet high. We know that already. But notice that the right triangle that we're dealing with, unlike the angle of elevation problem in the last screen, the right triangle that we're dealing with here does not involve the side of the tower as a side of the right triangle. Okay, because the angle of elevation is the acute angle between the observer's line of sight and the horizontal. And in this case, the horizontal regarding the observer is just an invisible horizontal line from his eyes to the edge of the earth. It's just it's an invisible line. But how do we get this drawing? Because we know that this little right triangle that we're drawing here has a height of 50 because the tower's height is 50, and since they are parallel lines and alternate interior angles are equal, then we know that they're equal, those sides are equal. We don't even need to know what this horizontal length is. All we need is a height. And what we have, of course, is the angle of depression, theta equals pi/7 radians. Alright, so doing the rest of this problem, of course, is just a matter of using the right trig function. And so sine pi/7 equals 50 over d. Sine pi/7 equals opposite. 50 is my opposite. It's the side opposite the angle theta. D is my hypotenuse. And so sine pi/7 equals 50 over d. And doing the necessary multiplication, I get d equals 115.24 feet. Classwork, page 309. Please write these numbers down. They're all word problems, and they're kind of fun. I know that sometimes trig you have to get used to it, but when you do get used to it, it becomes kind of fun because part of it's just the challenge of doing the right drawing, and those who like to draw enjoy it more probably than those who don't. But in any case, a big part of engineering, and certainly a huge part of calculus, is trigonometry. So it's good to become proficient at these problems.